I'm going to talk to you a little bit today about what we're doing here at GEOTAB as it comes to AI and data and machine learning and how we are doing that at scale. And, it's a combination of people and process and technology here that I'm going to talk about. First, I thought I'd start off just quickly a little bit about myself. Oftentimes it's a little difficult to have a bit of a personal feel here during some of these presentations that we're all sitting on all the time. It seems like 24 hours a day, 7 days a week now. So quickly about me, I'm a U of T computer engineering grad. Did that quite a few years ago now. And I went back for a second kick at the can, the inaugural year of the Masters in Management of Artificial Intelligence at Queen's University. I did that a couple years back because I thought that, this is what is missing in the world here, that kind of mix between understanding what to do and activate when it comes to AI, and merging that world with business was really missing in the industry. Actually, I think one of the presenters here, Advait from Google, he was in my class as well too. So it's great to see him as a presenter here. Prior to joining GEOTAB, I ran a small software company for about 13 years called Innovex. I was acquired by GEOTAB back in 2016. At that point in time, we were about 200 people, just under that, monitoring maybe 400,000 vehicles across the globe. At this point in time, we are over 1,600 people in the organization, and we're the world leading provider of commercial telematics to over 2.3 million commercial vehicles. So I've grown that team in our data and analytics department from 5 to over 90 now in the core center of excellence. Got a family out here in Oakville. You can see the 3 lovely little kids. One was born March 15th of last year. So we've had our hands full during COVID, certainly. And when it hasn't been COVID, my interests were skiing, theater, travel. You can see us over there in Iceland with our little one a few years back. And now it's been relegated to home improvement. So just quickly, a little bit about me. I want to echo the former presenters' sentiments there as well, too, because a lot of what we do, that data as a product, I use that term all the time. It's so crucial, and I'll talk a little bit more about it. And I think you'll see some commonalities in some of the things that I'm going to talk about, some of the things that he spoke about from Sinchi as well. So, at GEOTAB, we are on commercial vehicles, right? So just quickly about us, we have an onboard diagnostic port device that plugs into everything from some people do a 3-wire install on a lawnmower all the way up to Class 8 heavy duty vehicles. So it can be on passenger cars, trucks, you name it. And we're collecting a wealth of data from there. We're on over 2.5 million connected vehicles globally. Customers of ours are folks, any business that would have a fleet. So if I'm a UPS or a Pepsi or an enterprise, all customers of ours. And we're collecting about 50 billion data points per day. The map that you're seeing here is actually was drawn in a single day from vehicles that have a Go device, which is what our Telemax device is called, connected to it. Nothing to do with, something coming from Google Maps or OpenStreetMaps. So if you look at our device, that's what that little thing is over there. The Go 9 is the most recent incarnation of that. In there, we're collecting everything from GPS data. There's an accelerometer in there, so we're capturing acceleration in the X direction and the Y direction, the Z plane as well too, if you're looking at road roughness. In addition, it's really that IoT device for the commercial vehicle, because you can attach to it different things like temperature sensors, if you want to monitor, a thing like pharmaceuticals for cold chain of custody, or food being delivered to restaurants. You can do that. If you want to hook it up to a snowplow controller to see how much snow is spread on the ground, how much salt was spread on the ground, whether your windshield wiper blades are activating, all of this stuff, everything really rich engine diagnostics comes in via this device. We're not only doing it with our own device, which we've been doing for years, but we're bringing in data from a lot of the OEMs as well too. So direct without the need for a device, because it's really about what you do with the data once you get it. That's where our big value add is. We're creating that platform for people to access some really rich vehicle data and run their fleets. So folks like Ford and GM we're connected directly to. So that's kind of our core technology. If you were actually able to come to our office, which I extend the invite out to you whenever things do reopen a little bit more fully, we're out in Oakville. It's our head office location. We're situated globally, but our head office is in Oakville here in Ontario. You would see giant dashboards like this. So we truly do believe in management by measurement. That's our theme. And all of those dashboards that you see, they're actually just Google Slides. And we're an engineering company at heart. So what we did is we rigged together an apparatus that would use Python and interact with the Google Slides API. And we're actually refreshing these in real time. The reason we like that versus, a complex dashboarding solution for this kind of use case is that if I'm a sales guy or a CEO, I can just go into Google Drive and pick up any one of these dashboards. They're updated in real time. I don't need to make any configuration changes. It's readily available for me. And what's more, I can present them on these giant screens in the office. So we've got things that actually monitor our system's health, everything from stream delays all the way through to fun things like how many trips did our collective vehicles take to Mars and back in the last week. So data is at the heart of our culture in everything that we do at GEOTAB. I thought I'd talk about a few interesting data and AI applications that we certainly have to give you some insight into what we're doing. So we're using AI right now for a lot of predictive maintenance. So I can tell you, for instance, when your battery is going to fail in your vehicle, or when you're going to have alternator problems. And the way we do that is we look at the cranking voltage and temperature coming in from these vehicles, and at a very, very high frequency. And we've got models that we correlate with, specific failures. So we'll know, for instance, when a battery did fail and what did lead up to that, and develop models around that. So we actually, in the case of this specific model, we had to develop models that would actually invalidate or validate cranking events, because sometimes you might not have a nice curve. So we've got a model to do that, and then a model to actually predict failure as well too. So predictive maintenance is a big part of things that we do. We've got a lot of partners that work with our data as well too on our marketplace that do some really interesting things from predictive maintenance perspective. Intelligent transportation systems. So this is a new area of business for GEOTAB, and as you can imagine from the over 2.5 million kind of connected commercial vehicles, we're able to tell something about the world around us, right? So we can plot based on accelerometer readings where there are potentially dangerous areas for driving in cities. We know hyper locally where it's raining right now because the windshield wiper activation. We've got a logistic regression model that tells us, okay, based on this activity, we've correlated it with the weather network. We know the probability of it precipitating in a specific area at a local level. Freight bottlenecks, right? So understanding, where freight might be being detained, port activity. So we're able to really look at that supply chain. So again, in a very much so a privacy compliant manner, because that's really important to everything that we do. Vehicle recommendations. So a lot of the folks in the industry, they will provide recommendations based on comparison to how other vehicles are operating in a similar industry. We've taken a bit of a different tack on it. We look at an industry comparison isn't going to give you the right set of recommendations. You need to look at how that vehicle is behaving in comparison to similar vehicles. So we've got this notion of vehicle similarity and vehicle vocations. And that little kind of diagram that little embedded space model that you're seeing at the bottom there, every single dot represents a vehicle, and the proximity of one dot to another is its similarity. So what ends up happening is your kind of police vehicles cluster close together, your service and delivery vehicles cluster closer together based on movement patterns, based on the type of vehicle, all these things. So as a result of this, now we're able to tell you, well, we know what you should be doing from a fuel economy perspective. You're in the wrong vehicle. Or, hey, we can provide you a suitability assessment for electric vehicles. Based on these patterns of behavior, this fleet of vehicles would be suitable to replace with electric vehicles. We have one of the richest EV data sets in the world, supporting over 150 different types of electric vehicles and understanding state of charge. So some really cool stuff on vehicle recommendations. And then even bubbling it up further, during COVID, what we had done is we looked at the Johns Hopkins dashboard for how the healthcare system is, the different counts of COVID and everything. So we could do something similar for the commercial transportation, the commercial transportation industry. So we plotted a path back to norm based on different industries at a North American scale. So we could kind of see, okay, well, the construction industry seems to be recovering a little bit more quickly than let's say, long haul transportation, right? And so these are insights that we can draw out of the data because we're kind of pulling it in, and we can do this analysis in pretty real time. So those are a few interesting. There's tons more, but I thought I'd pick out a few kind of interesting ones that might resonate for you folks. To the point of the presentation, I thought I'd talk a little bit about a few things: people, process, and tech. So the people part of it, of course, can't be overlooked. I want to highlight that this is, one of the most important parts for me. I think starting with people as opposed to tech is crucial. I'll talk to you a little bit about how we run our organization. We've learned as we've gone. So at the beginning, there were 5 of us. Everybody's, you're a data scientist, an engineer, software engineer. You're everything, all mapped into one. Now we've got different tack of looking at. We've got 92 people in our center of excellence. That doesn't include the analysts that exist in other areas of the organization. We're not where I want to be from a male-female perspective. We're at 72% male, 28% female. Not bad for the industry, but we still can do better, I think. And then I'll talk to you a little bit about some of the teams that we've got here. So we've got a data product discovery team. And so this team is geared at looking at MVPs. How can I, quickly iterate and find what are those new data products going to be? And aren't concerned so much about making sure everything is scalable and robust, but let's quickly iterate on something. We've got our data ops and ML ops team, which again, that treating data as a product for the previous presentation here, guaranteeing that the single path to production for data at GEOTAB goes through data ops. The same with ML models. Any single path to production for machine learning models goes through ML ops. We already have DevOps, as many people have within an organization, but this treats data and machine learning models in a similar way. Our data platform team, they're geared at making these massive data ingestion platforms work really well for data ingestion and data digestion. Our infrastructure team, we use a lot of the GCP environment. So Google BigQuery actually requires infrastructure management, a significant amount of that. If you're looking at the way that Google BigQuery computes its usage, it's based on slots. And so you need a few folks looking at what your slot allocation looks like and how your resources are being controlled. So our data infrastructure team is concerned with that. Our data solutions team, this is where we have a lot of R&D, a lot of data scientists focus on everything from looking at fuel economy through to collision detection models, through to intelligent transportation systems. And this is where there's a collaboration between the data scientists, software engineers, and product managers. This is where these scale-up solutions really come to life. We've introduced a new notion of applied data scientist, who's that marrying up between product and between the data science team as well. Our agile services and education team, we run a series of data boot camps for our partners and internally as well too. They help us run these things, and we have a series of Scrum Masters that also help out with process throughout the organization. And then of course, privacy and governance, crucial to everything that we do, and we really do have a privacy by design focus on everything that we're putting out. In terms of scaling the Center of Excellence, so I mentioned we've got 92 on this core team. Well, we've also got analysts and data scientists scattered throughout the organization as well too, but it's about us talking together as one, right? It's not, what the embedded department is doing, what the support department is doing. It's like, how can we excel together? And we do that through things like our internal data analytics team on our Center of Excellence, help spread the word about, best practices. We have weekly all hands meetings with technical demos and presentation. We have the Google BigQuery police. If you're writing some people will write some crazy queries that cost a ton of money from a computation perspective. And it's help and guidance through chat forums of let's figure out how we can better structure these queries to be a little bit more efficient. And then from a career pathing perspective too. So the people are very important. The process for us, some of the things I've found really, it's been a challenge as you scale out, an AI team, a data science team in combination with product. The traditional SDLC, there's place for it, but it's different fundamentally because you're dealing with data, you're dealing with models, a little bit of unpredictability. So this is what I found has worked quite well recently. Our core team for a specific squad, is made up of a product manager who has the vision for the product, a technical project manager who's really task-oriented, concerned about making sure that we're meeting our deadlines, team of software developers because you're building something, and then an applied data scientist. So we don't necessarily have a series of dedicated data scientists for the core team, but that applied data scientist can now reach out to our R&D teams and say, hey, you don't need 92% accuracy on this model for it to be effective. I'm okay with what you've got now. Let's take it, bring it into product. And then we've got a shared service on data ops, ML ops, and our Scrum Masters. Those come from other departments, but if I want to activate a data pipeline or an ML ops pipeline, I can leverage resources from within the core DNA team, but that will help this core team as well too. So it's taken a bit to kind of figure out what process works, and this is working now. Inevitably, things will probably change, and we'll do things differently, but we just have to be very attuned because things are constantly changing in this world. Back to the point from the previous presentation, and this was I think brought about by Andrew Ng just even a few months ago as well too, and he had a real plea for it, and I really truly do believe it. We have to be more data centric in general, I think, and treat data as a product. The example to the right there shows that being very model centric sometimes yields minimal gains. Whereas if you were to be very hyper focused on making your data better, you can often see better gains in some of your predictions and your models. So I have a real strong focus at the organization at making sure that we are treating data as a product. We're not where we want to be yet, I think, but we're making a lot of advances toward that. And when we think of data as a product, what do I mean? I mean, it's everything from your data catalog, right? So we use open source. We use LinkedIn's Data Hub, quite good to allow us to build from an active contributing member to that community, everything from data lineage, accountability, acceptable usage policies, these kinds of things, anomaly detection for data quality, data residency, massive, because we're replicating pipelines in different jurisdictions because you absolutely have to due to data residency requirements. Our ingestion pipelines, monitoring those. Data privacy, keeping up with everything from the CCPA to soon to be CPRA to California to Vermont's new legislation to GDPR. How does that get imposed when you're thinking of data as a product? Data operations team to actually bring this all to fruition, and then the right stewards throughout the organization. So when we think of data as a product, it's not just about a catalog. The previous presenter went through a number of really, really excellent things that we've started to build up within our own ecosystem. So I'll talk about some of the technology we actually use to do this at GEOTAB. And in terms of the technology we use to build things to scale, just to give you an idea. So everything, again, starts with that little Go device, is on about 2 million vehicles. Right now we're at about 11 petabytes of storage, about 30,000 telematics records per second, with about a 5 to 10 stream delay from the time it hits our gateways to the time it's available for us to do work on that data in Google BigQuery. We can capture, events via Kafka stream in the meantime, but it lands in BigQuery within about 5 to 10 seconds. So data comes from, it's all through cellular network, hits our gateway servers on the Google Cloud. From our gateway servers hits cloud storage. And then we have a big data ingestion platform that we've developed on Kubernetes, leveraging Kafka. Very, very, very scalable, pumps all of that data to GBQ and handles thresholds and throttling that exists, because if you work with Google BigQuery, there's some limitations to that as well too. So we do a good job of kind of mitigating that. And then in Google BigQuery, very simply, there's a ton of pipelines built on Airflow. We've actually built a framework on top of Airflow that we call our data factory. And that allows us to submit jobs to Airflow pretty easily. And of course, there's a lot of Google BigQuery to BigQuery transfers, right? And we might leverage in Airflow. We might use Apache Beam or something else to parallelize some of the jobs that we're running. But we're doing that, and we also have a data digestion platform that we've created called DAS on Kubernetes again as well too. And the data digestion platform can either come from API points that are pulling from GBQ or from the Kafka stream. And then in between, we've got, we use MLflow a lot for our models. So all the models go to MLflow, and that can be pushed out to, our DAS APIs or to Airflow as well. Some of the core technologies we use at GEOTAB, so our data engineers typically use, so Kubernetes, of course, as we're scaling and as we, hit 1 million, 2 million, 3 million, 5 million vehicles. We have to make sure we do this stuff to scale. We use Kafka for our ingestion platform. Data flow we use to parallelize different kinds of jobs. So if I'm looking at, for instance, creating my machine learning model for predictive maintenance, our electrical systems rating, well, there's a ton of parallelization that has to happen there as I'm looking at creating features for my my cranking voltage. So we use data flow for that. We try to use technology that is open source, that is managed as much as possible. Sometimes we can't. Google BigQuery we're a massive user of that right now. I love that because you got some great spatial queries that you can execute there. You can take somebody who knows SQL and pump them into Google BigQuery. They're immediately successful. They've got some basic, machine learning that you can do within Google BigQuery, which has accelerated quite a bit lately as well too through their BQML. So good stuff there. And then our data scientists, most of them are using Jupyter Labs right now. Colab is used by some of the analysts in different parts of the organization because it's easy to get up and running. And then we're using everything from simple models on scikit-learn to TensorFlow, PyTorch, and have a cool faceting tool for helping us label things at scale. So these are some of the, it's not everything, but some of the core technologies we're using in the data and analytics division. And last but not least, I'll kind of end with this kind of statement. I think the foundation for good AI is absolutely good data. If we don't have good data, we don't have good AI. And this is what's going to allow us to innovate, build these next gen products. And so I'll double down on that. Treat data as a product as my kind of leaving message here. And if you have any questions, you can, of course, please reach out to me at my email address is there. My LinkedIn profile is there.
On the product side of things, it seems obviously you guys have a really interesting product. When you're kind of iterating on that, can you talk to us a little bit about how the products kind of came to be and maybe what you've learned over, I know product management is becoming a really hot sector in this space as well. If you can comment just briefly on kind of the product development and how maybe that's changed over since your time there at GEOTAB.
Yeah, it's changed, I will say quite considerably. There's a huge focus on product management. I find that you need product managers, but it's the combination of product manager plus technical project manager, which really allows for an activation of a team. I want somebody focused on vision. That's my product managers. And I want somebody focused heavily on the tactical day-to-day. That's my technical project managers, right? And of course, UX comes in tightly with that as well. So what we do is, because there's oftentimes a lot of experimentation that needs to happen within all the models that we're developing and building, whether it's predictive maintenance. So there's a lot of unknowns sometimes. So that applied data scientist that I mentioned there is absolutely crucial, because what that applied data scientist is doing is working very closely with he's a data scientist, but with a bit of a product angle to them, right? So knows what the product is looking for, knows enough to reach out to our research and development teams to say, hey, you know what? I think we've got something here, and we're going to bring this into product. Oh, you need label data? Let me work with product to capture that for you, and knows the right questions to ask, right? So it's really that translator. And then for kind of product discovery, it's a bit of a push and pull, right? So we've got our data product discovery team that is explicitly focused at working with our customers, with our partners, and it's fast fail, right? It's this MVP kind of approach, and that's where they kind of live and breathe, and the results of those learnings will fuel full-fledged products. So yeah, it's been fun.